In this lesson, we are going to start on 2D tensors. So a 2D tensor has two dimensions, as the name says. These are also called axes. So in this case, we usually represent it as a matrix, and the axis, we have the convention of calling this vertical axis as axis 0 and the horizontal axis as axis 1. And we also call these rows and columns. So index starts from 0. So this is column 0, column 1, column 2, column 3. Similarly, this is row 0, row 1, row 2. And we have our data points, C features. And typically you can take some data like you have, let's say you have data for housing prices. So you may have some features like number of rooms, size of the house in square feet, locality, and many other features. So these are the features. And then you will have data for one house. So let's call it price. So you have data for first house. It will have some price. Number of rooms is 3. Size is, let's say, 2000 square feet, and so on. Similarly, you will have data for another house, which will have a different price. Let's say 2000 units. Number of rooms is 2. Size is 2100, and so on. So if you combine this data, you will represent it in the form of a 2D array, in this case 2D tensor. So this columns, these denotes the features, and the rows denotes the data points. Similarly, you can have a grayscale image. You can think of this as a small grayscale image which has just 12 pixels. So each pixel will have some value. So for grayscale, it will be from 0 to 255. So this grayscale image can be thought of as a 2D tensor in PyTorch. Now let's see how we can create a 2D tensor in PyTorch. So it's very similar to creating a 1D tensor, that is using torch.tensor method. And instead of passing one list, we will have a list of lists. So you see this is the outer list, and within that you see a few inner lists. So the first list denotes this first row, second list denotes the second row, third list the third row. So you have a list of lists. Sometimes you also write them in the matrix form, like 1, 2, 3, 4, comma, and this is the outer matrix, 5, 6, 7, 8, and so on. So it looks like a 2D grid. Now let's see some of the methods and attributes of 2D tensors. So if you call n dimension, it will return 2 in this case. So this is true for other dimension tensors also. So this is a 2-dimension tensor, so it will return 2. Now x dot shape. So shape attribute will return the size of this tensor. So it will call tensor dot size, or it will return a size tensor which will have a dimension of 3 rows and 4 columns. The size method also returns the size of this tensor, number of rows and columns. And num elements returns the number of elements in this tensor, which will be equal to number of rows multiplied by number of columns. In this case, it will be 3 multiplied by 4, that is 12. Now let's open our Google Colab notebook. So we have created a 2D tensor. So let's print it. First need to import the torch. So it prints in the 2D matrix form. Now let's say I want to access the second row, third column, or rather third row, fourth column, since index starts from 0. So 2, 3 will denote row number 0, 1, 2. So if you see this example, then this is row number 0, row 1, row 2. Similarly, this is column 0, column 1, column 2, column 3. So 2, 3 denotes second row, third column, which is 12. So you can write, if this is A, then you can write A2, 3, or you can also write A2, 3. Both are same, and both will return 12. If you want to find, let's say 6, you will write row 1 and column 1. Similarly, here we have 2, 3 which returns 12. You can also write it in other form. Here these are comma separated, here these are in separate square brackets, and n dimension should return 2. Shape will return 3 cross 4. Similarly, size and num elements will return 12. So in the next lesson we will see indexing and slicing for 2D tensors.